Hello, parents and any teachers or students who may be watching. Welcome to Creating Math Ahas. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to look at some subtraction strategies that we use to solve grade 4 problems. In this video, we're actually going to be focusing on mixed number subtraction, so fractions. Now, if you want to see the same strategies used for whole numbers, like 3-digit, 4-digit subtraction, the 3-digit subtraction examples were done in grade 3. So if you look at the grade 3 video, you'll see how these strategies are used with whole numbers. But as I said, in this video, we're going to focus on grade 4 and subtraction with fractions. Now, notice I have two fraction kits here, one much larger, one smaller. I want you to notice something. In your children in grade 3, 4, 5 may be asked to make fraction kits. And there are some key things that I usually ask teachers to do when they make the kits and some things for you to think about. One is I don't model for the children how to fold something into two equal pieces, 4, 8, 3, 6 equal pieces. Because one thing we've learned is it's that struggle to make a fractional unit that's really important. So we might give them Play-Doh, we might give them paper eventually, and get them to work out how to get the two equal pieces or 3. That is problem solving to them. Another thing, though, that you may notice is these are construction paper. These are 1 inch wide. This is normally the one I would have your children do. 1 inch wide, 12 inches long. I do have two equal pieces. And you notice how I said 2, 4, 8? Then I went back and said 3 and 6, and sometimes 12 will do, because it's the repeated halving that is really important. If you can fold it into two equal pieces, then 4 becomes easy because you fold each of the halves into two equal pieces. And you fold each of the fourths into two equal pieces. So, sorry, two equal pieces. Then I go back to thirds, right? 3 equal pieces, 6 equal pieces, 12 equal pieces. That equal piece idea is really important for fractions. So you may hear the teachers using equal piece language before they use halves, fourths, and eighths. So that's an important thing to just understand. You may see that with your child's teacher. The other thing I hope you'll notice is none of these are labeled. Some schools, some classrooms, you may see some plastic versions of fractions. And you may see that they've actually named them. They might have written on them 1/2, 1/3, 1/4. I've seen some where they've written it in multiple ways. Like I've seen some where you might have 1/2 and then you might see 5/10, or you might see 5/10 as a decimal. They've labeled and named each of the pieces. And if you notice, I haven't labeled them, and that's very purposeful. The reason for not labeling them is to know how to name a fraction, you have to figure out how many pieces of that total the whole. We name this 1/2 because I need 2 of those to equal my whole. Same would be true with this version. I know this is 1/2 because I have 2 of them to equal the whole. The minute it's labeled, it's a reading activity. I just have to read its name. This name is 1/3 and 1/4 and 1/6 and 1/8. But I don't know why you named it necessarily. You see, it's very purposeful. We don't label these so that they get a sense of how do you name the fraction, how many equal pieces equal the whole, and it gives me embedded practice when I don't label. So I hope you see that when we use these manipulative materials, we're helping build your child's conceptual understanding of what they're doing. And we're doing it in purposeful ways to build connections. And even though technically labeling it will be easier, we lose that practice we need your child to have. So sometimes you'll see things aren't labeled, so we get the practice. Now, in the introductory video, I mentioned, I guess it's 3 main strategies: round and adjust, decompose a place, And for us with fractions, it will be decompose a whole, and then also a counting up strategy. So I'd like you to think about this type of a kit. So you can see I have extra holes. I've already cut these into my pieces. I'd like you to notice also that these pieces, I'm going to draw related pictures that'll look like strips, and that becomes important for us, whatever grade we're learning the strategies in. Now, let's start with a problem where we're going to have enough of the units that we need. Let's say I'm going to remove 2 1/4 from 5 3/4. Now I could do this. I could have 5 of my holes in 3 1/4 pieces. I can put these out. I can put out the 3 1/4 pieces, and I'm going to remove, right? So if these are my 1/4 pieces, I've got 3 of them. The idea is I should have enough holes and enough 1/4 pieces here that I remove 2 of the holes, 1 of the 1/4 pieces. I have enough in this type of problem. These are easy. If I draw the related picture, as I said, I'm going to draw pictures that look like that strip model. And I'm going to get the force. So this would look like my model. See, I've got 5 3/4. I want to remove 2 1/4. So I'm going to remove 2 of the holes. It doesn't matter which 2 of the holes. I can remove any 2 of them. And I'm going to remove 1 of the 1/4 pieces. I'm going to remove like size pieces. Okay, so I can remove like size pieces. And in this case, I'm going to end up with 3 2 1/4 pieces left over. Okay, those problems are simple because we have enough of the units, and I have like size units. Now notice how I'm focusing on the size of the unit, not the denominator when I'm talking with you. It's technically getting the same denominator, but when we were hearing you must have a common denominator, I saw that as kind of a rule. I had to follow that rule, and I wasn't thinking about sizes of pieces I'm removing, right? So we'll look at that in a little bit, but it's same size units. I remove fourths from fourths, holes from holes. I remove eighths from eighths, okay? If I'm trying to remove 16ths from eighths, I've got to do something to those 1/8 pieces so that I can remove 16ths from 16ths. That's what we're doing when we get a common denominator. We're getting a common unit fraction piece, fractions with that, okay, 1. So anyway, that's our start. These problems are easy enough because we have enough of the pieces. But what if I was instead trying to take 5 1/4, we switch it around, and I want to remove 2 3/4. Now, to do that problem, it would have been a regrouping type problem. I would have had to borrow something, is the term that they used when I was in school. But let's look at the same start. I'm going to start with my 5 holes. And I have a 1/4 piece. And we're going to look at the strategy called round and adjust. See, one way to remove 2 3/4 is to remove 3 holes and give 1/4 back. Right? I round, I think of this as 3 holes. It doesn't matter which of the holes I remove 3 holes. So I think of this when I'm removing 2 3/4, I think of it as removing 3 holes, and then I have to give back a 1/4 piece because I removed too much. Round and adjust. Very efficient. it turns a problem that I would have had to use paper and pencil for into a mental arithmetic problem. I can remove 3 from 5 1/4 in my head, and I can give a 4th back. Easy enough. Okay, round and adjust. Another one for the same problem. I'm going to start with the same starting point of drawing my 5 holes and my 1/4. And I could use this using those pieces and actually act it out with my holes and my parts. But I'm going to start with the 5 and the 1/4. And this time I'm going to decompose a hole. So what I'm going to do is I need to remove 2 holes. Doesn't matter which of these I remove. I'm just going to remove the top ones again. I remove 2 holes, and then I'm going to decompose one of the holes into 4 1/4 pieces. Now I'm ready to remove 3 of them. So I could remove these 3. I could remove these 2 and this one. It doesn't really matter, but I'm decomposing a whole because I need to think of this as 3/4 and 1/4. So I can remove any of these. I'm going to remove these. And what do I have? I still end up with 2 holes and 2 1/4 pieces. Okay, decompose a whole. Now, some children work a little differently when they're going to decompose a whole. Mathematically still sound what they're doing, the strategy that they're using. They have that 5 and 1/4, but to remove 2 and 3/4, they'll remove the 2 holes, no problem. I'm going to remove, these 2 holes this time. Okay, doesn't matter. And then what they do is they remove this one. And they think about, well, this is 2/4 and this is 2/4, so I remove 2 more 4s. They'll just cut it in different ways, or they'll remove different pieces. All still works for decomposing a whole. Decomposing and thinking about how we can remove for what would have been regrouping, complex regrouping problems. Decompose a whole, round and adjust. Now, I want to show you one more technique, and this is a count up strategy. And you might see we've looked at this tool in grades 2 and 3. This is a total part chart or a part total chart. We use this organization to help us count up. And essentially what we do is we put the total we're trying to think of up here. And we think of our subtraction problem a little differently. So let's say my total I'm trying to get to is 5 and 1/4. Okay. I have part of it here. I have 2 and 3/4 sitting over here. I could think of this. Here's my 2 pieces. And I've got 3 1/4 pieces. And the idea is I'm going to have to count up, and I'm going to be thinking of this problem in this way. How many more than 2 and 3/4 is 5 1/4? Okay. How many more than 2 and 3/4 is 5 1/4? I'm doing comparison, I'm counting up. Now see, what can I do? If I add in a 1/4 piece here, I'm now at 3 holes. I can add in 4 holes, 5 holes, and then a 1/4 piece. Let me show you those. So since these are running off, Let me just show you with pictures. Essentially what I can do is I start with the 2 and 3 1/4 pieces. And I'm going to count up, or I can do this where I'm actually coloring in different colors and counting up. But what do? I need a 1/4 piece. That's going to fill in that. That's 3 holes. Then I'm going to need 4, 5, and another 1/4 piece. 5 1/4. Now I started to draw it, and let's just draw it where we're not confused with this model perhaps, but let's start here. You may see your child seeing some models instead of side by side like that one, which for some of your children that works well. For others, it's a little, they can't see how the pieces fit together. Here's my 2 3/4. Well, what can I do? There's the 1/4 piece. That gives me 3 holes. Can you see that a little better, how it can slide up in? And then I've got 3, 4, 5, and then it won't matter where I draw this other 1/4 piece. So how many more than 2 3/4 is 5 1/4? Oh, well, it's 2 2/4 more. Now you may see, instead of a blank, we're trying to transition your children to using unknowns. And you may see in the earlier grades an unknown as a star or a box or some little label. And you can see here I'm using a letter. Notice how I'm using the word unknown, not variable, because this will not have multiple possible answers. This has a single answer, right? But I have this unknown, and in our case, the unknown is 2 2/4. Okay. Now, when I was at school, you were always required to write this in a simpler form, meaning how can I make that same size using the fewest number of pieces? And so conceptually, that's what we're going to think. How could I make this size using the fewest number of pieces? Well, I could do it with a 1/2 piece. So there are ways when we're working with fractions that we can actually get them conceptually understanding what's going on versus trying to divide and multiply and remember all the facts. They see how the pieces fit together. Okay. Now, that's one way to count up. Let's do a different way to count up. I'm going to stick with the same problem. Okay. But this time, instead of actually using that fraction kit model, I'm going to use a number line model. And your children may be seeing what's called open number lines, which really is just a segment of the number line. We don't have to start at 0. We don't show them all of those marks in between, okay, all the hash marks and all the increments. We can start at 0. We can do or start at someplace other than 0, excuse me. We can just look at the segment, and we're still in this case trying to determine how many more than 2 3/4 is 5 1/4. Or I could have written it this way: 5 1/4 is how many more than 2 3/4? There's lots of possibilities, right? So we're looking at jumps. And this is where benchmark numbers, key numbers come in. And I apologize that this will not be to scale, right? But here I could make a jump to 1/4. See, a benchmark number is a whole number, right? I could make jumps of 1/4, continue doing that. Nothing wrong with that, but not efficient. I could make a jump of 2 to get me to 5. And then I do another jump of 1/4 to get me to 5 1/4. So this is a counting up strategy, a different version of the counting up strategy. We had decompose a whole. We had the round and adjust. And I did it with like size units. Let's say instead of removing force, I wanted to remove 2 7/8. Now, think of round and adjust. What can I do with round and adjust? To remove 2 7/8, you can do this in your head, right? I can remove 3 and give back 1/8. Now, in terms of my picture, let's do our picture of 5 holes and my 1/4 piece. Okay. To remove 2 7/8, I can remove 3 holes. And then I'm going to have to give back an 1/8. So a 1/4 would be there, but I'm giving back this. Now, to be able to name this, remember I said we had to have same size units, same size pieces. I'm going to have to cut this into 8ths. So to remove this, I end up with 2 1/4 plus an 1/8. Well, I need to think of 1/4 because I need the same size units to combine as 2 1/8 pieces put together with a 1/8 piece. We move 2 and was it 7/8? And I want to decompose a whole. I'm going to start with the same type picture. But remember our other is decompose a whole, right? Decompose a whole. So I'm going to remove the 2. And this time I'm going to decompose this into 8ths. And I'm going to remove 7 of them. Now remember, it doesn't matter which 7 I remove. I could remove this 7, I could remove this 7, I could remove these 2 and these 5. And because of the way I just had this cut, I also see, oh, there's your 8th pieces. So I can decompose a whole. I could, and I'm still going up with 2 holes and 3 1/8 pieces. I could do the same idea for counting up, whether I'm using the fraction kit or I'm using an open number line. See, the beauty of these strategies is they work for whole numbers, they work for mixed numbers, they'll work for decimal numbers. I'm learning a strategy beginning in grade 2, and they're mental strategies, many of them. It's nothing new in math. It's just that we're using strategies that don't send them straight to trying to recall a procedure. It gets them thinking in terms of what it looks like, what they're doing symbolically looks like, and then it's easier to know how to get to those answers. And this one, it's the same idea. I can do a jump of 1/8 that gets me to 3. I can still do a jump of 2 to get me to 5, and then I do a jump of 1/4 to get me to 5 1/4. Now, some of your children, because they're comfortable with certain procedures, they will just do a jump of 2 3/8 and say, there you go. They represented the answer, not the process for getting. They're losing the benchmarks in doing that. Now, there's nothing wrong with that. I mean, they're showing, but this technique is what is helping us get to the decimal arithmetic we want them to do. Understanding what they're going to be seeing in some story problems of getting to certain mile markers, certain key numbers that they're wanting to work with. Now, if I want to make this more challenging, I don't need to make these fractions more challenging. What I can do is say, do this in exactly 7 jumps, 1 must be 1/2. See, that makes the problem more complex. Same thing here. If I want to go back to that problem that we were doing that was all in force, I can do the same idea. I want you to do this in exactly 6 jumps. 3 must be 1/4 each. See, by putting restrictions on number of jumps, how long the jump is, that's how we can get at a much more complex problem. So I hope in this video you've seen how we can use round and adjust, decompose a whole, count up, those same subtraction strategies with mixed number subtraction, which takes what was really quite complex, at least to me, it was quite complex in school when I had to regroup with a fraction and I wasn't just crossing out and putting a 1 up there. It gives me strategies for getting that, and it keeps me understanding about the benchmarks and about the size of the units that connect me back to these fraction kit pieces, those models that we first make when we're working with fractions and looking at relationships between them. So if this video has helped you understand some of these strategies, please give it a thumbs up. Please click on the bell notifications and subscribe so that you know when other videos are coming. If you have children in other grade levels, I hope that you will take a moment to look at those grade-specific videos. And thank you so much for watching.